Alright guys, today we're going to identify the multiplicity of a function. Now it's important to understand that a multiplicity is simply any repeating zeros, okay, or roots. So in order to figure out what the multiplicities are of this function, we have to identify what the roots are, or also known as the zeros of this function. And in order to do that, we can see that we have a cubic, so we can't use the quadratic formula here. So we're going to have to try to factor this. Right? And looking at it, we have two terms here and two terms here. We could possibly try to factor by grouping here. So why don't we try that and see if it works. So we're going to try factoring by grouping. Again, I have videos on this, so if you're not sure what factoring by grouping is, make sure you check that out. Alright, so we have our first two terms and then our last two terms. And then we want to see what is the greatest common factor we can pull out of these first two terms. Well, that's going to be x squared, and then we're going to have x minus 12. Okay, and then we look at our last two terms. Well, what is going to be the greatest common factor there that we can pull out? All right, and in this case, it looks like it's going to be 16. So I'm going to pull out a 16, so plus 16. And then I'll have 3x, and this will be minus 4. Okay. Well, when you factor by grouping, you need to look at your common factors here. All right, so I have a common factor here and a common factor here. Well, you may notice that they're different. Okay, so unfortunately, factoring by grouping is not going to work here. All right, because these, also known as our common factors, are not the same. So we have to go about another way of trying to factor this. Okay, so let me erase this. So it looks like we're going to have to use the rational root theorem. Okay, and again, I talked about this in my other videos, so make sure you watch that if you don't know what the rational root theorem is. And the rational root theorem simply just states we're going to have p over q, where p is my constant term and q is my leading coefficient, okay? And we're just going to figure out the factors, okay, of each. So what are going to be the factors of negative 64, and what are going to be the factors of 1, because there's really a 1 here, right? Well, we're not going to get all of the factors of negative 64. We'll just start off with some of them, and then if we need more, we can always get more. So the first one will be plus or minus 1, plus or minus 2, and then we'll have plus or minus 4, okay, and why don't we just stop there for now. There are more, so if we need more, we can always get more. And then my factors of my leading, okay, or my q is going to be plus or minus 1. Alright, now we just simply do this out. So we're going to do plus or minus 1 divided by plus or minus 1, well, plus or minus 1, right? This will be plus or minus 2. It's 2 divided by 1. 4 divided by 1 plus or minus 4. Okay, so these are some possible rational roots. Now remember, when you're using the rational root theorem, we're going to have to use synthetic division. Alright, so I'm going to set up my synthetic division. So remember, we don't skip any terms here, so we don't have to put any zeros in for the coefficients. So we're going to put 1, negative 12, 48, and negative 64. Okay, and here's my synthetic division bar. And we just want to pick a factor that we think could possibly work here. So I'm going to try 4. And we'll see how that works. Let's try 4. And remember, if 4 is in fact a root of this function, we'll have a remainder of 0 at the end. All right, so that's what we're going for. So let's go ahead and use synthetic division. So we're going to bring down the 1. So 4 times 1, well, that's 4. Then we have negative 12 and a positive 4, that's going to be negative 8. Negative 8 times 4, that's negative 32. And then we have 48 minus 32, that's going to be 16. Okay, and then 16 times 4 is 64. And then a negative 64 and a 64, well, that's 0. So what that tells us is, yes, this is in fact a root of this function. So what I'm going to do is write it up here so I can keep track of it. So 4 is a root or a 0 of this function. All right? Now remember, we just did synthetic division, and whenever we do division, we naturally lose, okay, a degree here. So now this is really x squared, x, and our constant. Right, and if you wanted, you could keep testing out different possible rational roots here, but remember, this is only testing for rational roots. There's a possibility that I could have an irrational root. So once you get it down to a quadratic like we have here, I really suggest that you go about factoring it, because factoring will give you the definite answer. All right, so that's what we're going to do here. Now that we have it down to a quadratic, we're going to try to factor the rest of this out, right, to get our remaining roots. So I'm going to go ahead and write out what this is, then we'll erase. So we have x squared minus 8x, and then plus 16. Okay? And let's erase this. So we have x squared minus 8x plus 16. Okay. Alright, let's go ahead and do the AC method for factoring here. So a times c, that's going to be 16. So what two numbers when I multiply are going to be 16, but add up to negative 8? Well, that's going to be negative 4 and negative 4. And then remember, we also have one of our roots here, x equals 4. Well, if we put this back into factored form, right, this will be x minus 4 equal to 0, right? So we also have another factor here of x minus 4, and again, this is all equal to 0. All right, so this is completely factored out. So what we need to do now is determine the multiplicity of each root. Well, we can see here when we take each one of these factors and we set it equal to 0, we'll get x equals 4, x equals 4, and x equals 4. So 4 is occurring 3 times here, meaning, okay, our roots, we could say, so x equals 4 with multiplicity of 3. Okay? So that is identifying the multiplicity. So we would have 4 with a multiplicity of 3. Okay, so that would be the answer there. Let's try another example. Alright guys, so here is our second problem. Again, we're trying to identify the multiplicity of this function. So again, we have to get the roots, or the zeros, of this function. And remember, the roots are always where it crosses the x-axis. So the y value will always be equal to 0 in that case. Alright? So we're going to have to try to factor this. Again, it's not a quadratic. Can't use the quadratic formula. We could use the rational root theorem again here. But if we take a look at this, there may be actually an easier way to go about factoring this. Okay, and we can actually use the AC method on this, and I talked about this in another video on how to factor non-quadratics using the AC method. Alright, so if you haven't seen that video, definitely give that a look. But we're going to go about factoring this a different way, okay, than the first example. So I'm just going to manipulate this equation. I'm going to rewrite this. I'm going to rewrite it as x squared to the second power minus 13x squared plus 36 all equal to 0. And then I'm just going to give x squared a value, alright? I'm going to assign it a value. So we have an x squared here and an x squared here. I'm going to say that x squared equals u, alright? You can call it whatever you want. Let's call it u here. So anywhere that I see an x squared, I'm going to replace it with a u. So if I replace this with a u, this whole thing here will just be u squared. So now I have u squared minus 13, well here's another x squared, sine of u, plus 36. This is all equal to 0. And we can see now that this is a quadratic, right? Remember the definition of a quadratic, the equation of a quadratic is going to be ax squared plus bx plus c. Okay, and we can see that we are in that form. So knowing this, we can use the AC method now to factor. Okay, so a times c. So we get 36 times 1, that's just going to be 36. What two numbers when I multiply will be 36, but add up to negative 13. Well, that's going to be negative 9 and negative 4. And I'm just going to rewrite this as u minus 9 and u minus 4. And again, we're all equal to 0 here. Okay, so we have it at this point. I'm going to go ahead and erase some of this work so we can finish this off. So just writing above now. We see that we have a u here. Well, going back to what we originally assigned u to, we know it's going to be x squared. So anywhere I see a u now, I'm just going to replace it with x squared. X squared minus 9, and we have x squared minus 4, all equal to 0. Well, this is a difference of 2 squares, and this is a difference of 2 squares, so we can factor a little bit further here. We can have x plus 3, x minus 3, and then we can have x plus 2, and x minus 2, okay? Alright, almost done. We didn't just solve now for each one of our factors, so when we solve this, we'll get x equals negative 3, we'll get x equals 3, we'll get x equals negative 2, and we'll get x equals 2. Alright, so we're going to go ahead and write this out. We have x equals, we said negative 3, 3, negative 2, and 2. And these are all going to have a multiplicity of 1. Again, because they're only occurring one time. Alright, so this would be your final answer. And again, these all have a multiplicity of 1. Alright, and that is how you identify the multiplicity of a function.